Pre-calculus, we are on Unit 7, Day 7, Real Roots of Polynomials. You will need a graphing calculator today. The types of problems we're going to be kind of working through today are, you're going to be given a polynomial, you're going to be asked to analyze the zeros. So we're going to look at some theorems that can help you with that. So we'll go ahead and start with the remainder theorem. So if you've got a polynomial, okay, and it's a dividend divided by the divisor, so f of x divided by g of x. You're going to get something, right? So if you have 10 divided by 4, well, 4 goes into 10 2 times evenly, but there's a remainder. The remainder is this r of x over g of x. Why is it over g of x? Because, as I explained in my previous video, once you get your remainder, it goes over the original divisor. If you need to watch the previous video, go ahead and do that. Another way to write this is if I took the entire equation here and I just multiplied through by the denominator, that would give me f of x equals q of x times g of x plus r of x. Okay, so the remainder theorem says let f be a polynomial function if f of x is divided by x minus c. Okay, in that form x minus c, then the remainder is f of c. So for example, says example 1 says use synthetic substitution to evaluate the function at the given value. So if you're given a polynomial, yes, you could just plug in 3. That's the easiest method to use to go ahead and use the remainder or the factor theorem. If you go ahead and what is f of 3? Well, if I plug in 3 into my original equation, I get 3 cubed minus 4 times 3 squared minus 5. That gives me a negative 14. That gives me the same value if I use synthetic division. So if I plug in, if I divide x in the form x minus c, right? Here's our c, 3. And I use the coefficients. Okay, 1 is for x squared, or x cubed, sorry. Negative 4 is for x squared. I have 0 x's, and I have negative 5 as my constant at the end. And you go ahead and you divide. What do you have left? Negative 14. Okay, so there are 2 methods to these. Yes, you can use synthetic division. You will get the same answer as if you plug in the value. F of negative 2, you should get negative 29. So the factor theorem says let f be a polynomial function, then x minus c is a factor if and only if when you plug that value in you get 0. So these are not factors. X minus 3 is not a factor of this polynomial because it didn't go in evenly. I have a remainder. So if I take a look at example 2, okay, and it says use the factor theorem to determine if the factor is if it's a factor of a given polynomial. So we're going to go ahead and oh wait, I already have that one done. Okay, so we're going to go ahead and divide through using the synthetic division by c, which is 1 in this case. And then we have our coefficients are 2, negative 1, 2, and negative 3. And then I go ahead and start by bringing down the 2. 1 times 2 is 2. Negative 2 plus 1 is 1. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. Ooh, look, 0. So if I were to plug in f of 1 should be, when I plug that in, I should get 0. Should go in evenly. So x minus 1 is a factor of this original polynomial. And now I go ahead and try negative 3. And I see that there is a remainder. So that means that x plus 3 is not a factor of the original polynomial. All right, so Descartes' rule of signs is actually quite useful, especially when you don't have a calculator and you're trying to figure out how many possible positive or negative zeros you have. So I'll go ahead and read this to you. So this guy's a pretty famous French mathematician and philosopher in the 1600s. Let f denote a polynomial function in standard form. The number of positive real zeros of f equals, and here it is, the number of sign changes in the coefficients of f of x, or is less than that by an even number. Okay, so and the number of negative real zeros of f either equals the number of sign changes in the coefficients of f of negative x, or is less than this by an even number. So I'll explain to you what that means. So if I've got a polynomial here, in example 3, find the number of possible positive and negative real zeros. All right, so if I go ahead and look at the original terms here, I go from the first term has a negative to a positive. So that is one sign change. So the next one, there's no sign changes from a positive 4 to a positive 3. But from 3x squared to negative 2x, that's another sign change. So it looks like we have two sign changes. So f of x has two sign changes. So f of x has 2 or 0. Okay, you subtract 2 from that, whatever that number is. You could also have, see it says up here, or is less than this by an even number. So if you had like 5 changes, 5 minus 2 is 3. So it could be 5 or 3, or it could be 1. Now, for the negative sign changes, we are going to have to substitute in negative x and figure out what that is first. So let's go ahead, and if I were to plug in, and you can most of the time do this in your head, but for the first time I'm just going to show you. If I plug in a negative x and my coefficient is odd, what's going to happen is I'm going to end up with an extra odd sign there that's going to be multiplied by this 3. This is going to end up being 3x to the negative times negative makes this positive, right? And then plus this becomes, let me just go ahead and write this out first. Okay, so this negative x is being multiplied by itself an even number of times. So that's just going to turn out to be 4x to the 4th, right? Same with this x squared. That's just going to be 3x squared, because a negative times a negative is going to be a positive. This sign's going to change because it's going to be negative times a negative, which makes that a positive 2x, and then minus 1 will stay the same. Now we go ahead and look at the sign changes. Well, we don't have a sign change now between x to the 7th and x to the 4th. We don't have a sign change between x to the 4th and x squared, and it looks like, oh wait, that's a plus, right? That's a plus 2x. Okay, no sign change there. And it looks like there's only one sign change between positive 2x and negative 1. So f of negative x has one sign change, and we can't subtract an even number from that, otherwise we'd have a negative value. So f of negative x has one negative real zero, which is going to be great when we're guessing, when we've got this list of zeros. Once we get 2, or if we have 0 positive zeros, we know we can stop, because we can't have any more than 2, and it has to have one negative. So you'll generally get a problem like this where it's really not going to be that easy to factor by grouping. I mean, if you can factor right away and be done, great, okay? But in this case, or if you get a problem that's a lot more complicated, so we go ahead and we look at what are the number of possible real zeros. Well, we look at the highest degree. In this case, it's 3. What are the possible positive zeros and negative zeros? Okay, well, if the positive zeros, if I go ahead and look, no sign change. Let me erase that. Only do the sign changes. Only one sign change. So it looks like there's one 0 that's positive. Now for negative, if I go ahead and plug in, try just like we did in the last problem, negative x, what do I get? I end up with negative x cubed, well, to positive 11x squared. That's one sign change, and it looks like there's one more sign change here. So we could have 2, or we could have 0. Negative zeros. Okay, so now let's go ahead and list out the potential real zeros. So to do this, all this is a lot of people think this is very confusing in Algebra 2, but it's really not. It's the factors of the constant term, which in this case is plus or minus 6, okay, it's constant at the end, over the factors of the leading coefficient. In this case, it's plus or minus 2. So you can go ahead and list the factors, write your plus or minus first. So you write plus or minus. What are the factors of P? P is the plus or minus 6. So what do numbers go into 6? 1, 2, 3, and 6. And the factors of Q are just 1 and 2, right? Plus or minus 1 and 2. So all the potential zeros, I have to list them out. Okay, I'll put them right here. plus or minus. So we're going to take all these numbers and put them over these numbers. Now, if you put all those numbers over 1 or plus or minus 1, you're just going to get the same thing, right? So 1 plus or minus 2, right? Plus or minus 1, 2, 3, and 6, okay? Now I have to take all those numbers and put them over 2. So if I put 1 over 2, that's new. That's 1/2. If I put 2 over 2, that simplifies to 1, which is already on my list. If I put 3 over 2, that's a new number. We have to add that. And 6 over 2 simplifies to 3, which is already on my list. So here is the list of potential zeros, which we know already only one of them is positive, and 2 or 0 of them are negative. And we know there's a total of 3. So what's going to happen is if we get one positive and we don't have any negative, then the other 2 that are left over, because we have to have 3, are going to be imaginary. So let's just see what happens. So at this point, it's probably easiest to go to your calculator, type your equation in, and take a look. I can already tell there's going to be 3 zeros here. One's positive and these 2 are negative, okay? But let's go ahead with, start with 1, okay? And if I go ahead and divide through by my 0, 1, I end up, it goes in evenly. So that means that these are the leading coefficients of what's left over. Okay, we've divided an x out. So this x, this 2 represents originally the leading coefficient was for x cubed. It's now going to be for x squared. So what we have left is this trinomial. I think it's in your best interest at this point to not continue dividing. You can if you want, just like we did, but I think it's easier to go ahead and just factor it since it's a trinomial. So if you go ahead and factor it, you will see you've got, if I set 2x plus 1 equal to 0 and x plus 6 equal to 0, here are my zeros. And you can check that by looking at the graph. Okay, so we got negative 0.5 and then negative 6. If you decided at this point, rather than checking it, if you wanted to go ahead and continue dividing, you could divide through by negative 6. And if you did that, it would look like this. You would start, you would just continue dividing right here. You would start, okay, we already divided by 1. Now let's go ahead and divide through by 6. You would not start over from the original polynomial. You bring this 2 down. 2 times 6 is 12. Okay, so this is 25. Hold on. Something's not right. Negative 6. Okay, so negative 12, that makes a lot more sense. 1, negative 6, 0. So then you would see this becomes 2x minus 1. So you can't forget your other factors would be x plus 6 and then x minus 1. And that, I think, is what's asking at the end here. Yes, write the equation in factored form. Don't forget the original 0 that you pulled out when you divided. And that's it. I'll go ahead and quickly show you this one, but this is a you try. You can look at these answers on your own, see how you did. I'll leave that up for just a second, because I want to get to this last example 5 very quickly. Okay, so to find the value of k such that f of x equals blah, blah, blah. Okay, so and we've got a factor of x plus 2. We're dividing by x, negative 2. So we go ahead and start by bringing down the 1. 1 times negative 2 is negative 2. Now this is negative 2 minus k. Now we're going to multiply again. So that becomes negative 2 times negative 2 is 4 plus 2k. Now I'm adding that k, so I'm going to get 4 plus 3k. And now I am multiplying again, so that becomes negative 8 minus 6k, and negative 8 minus 6k, and this becomes 16 plus 12k, and that becomes 17 plus 12k. So my remainder is 17 plus 12k. Well, I want my remainder to be 0 because I want it to go in evenly. So I'm going to go ahead and solve this equation here for k. That makes k should be negative 17/12. If I find the value of k such that has a factor of x plus 2. And just make sure that you put in 0 because you don't have any x's. So you have to put a 0 in for to represent the number of